Alright, so for this problem, I'm going to focus on the actual bomb calorimeter. And so in the previous, and long ago in lecture, I've already kind of given you a practice problem over the coffee cup calorimeter, but I just want to kind of go back and refocus on the bomb calorimeter just because it's kind of a little bit different. And so you have to remember with the coffee cup calorimeter, we actually used what we call the specific heat capacity. And so that MCAT equation, that C there is a specific heat capacity that has a unit of mass. And so when we talk about that, that's why you have to have the mass unit inside that whole MCAT equation. When we talk about a bomb calorimeter, things are slightly different, mainly because the bomb calorimeter is strictly set up so it's actually just going to be measuring a change in temperature results in a change in some type of energy. And so a bomb calorimeter uses a heat capacity. And so please notice I said a heat capacity and not specific heat capacity. And so a heat capacity is only going to give you a terms of kilojoules or terms of energy per change in temperature. And so in these cases, this is just, again, a ratio between your actual energy and your temperature. No unit of mass is included in here. And so we kind of go through and start actually talking about the heat combustion. When we refer to a bomb calorimeter, usually mass is kind of left out of the whole deal when it comes to the calorimeter. But please notice that I do have something in terms of units of mass here. And so usually the last step of the calorimeter equation, problems, usually includes kind of figuring this stuff out. Heat of combustion, we can figure that out using solving for E. But when we talk about this, it's usually per gram. And so you usually have to know the mass of your sample. You just usually kind of throw it in there after you did all the other E calculations and everything else. And so when we talk about a bomb calorimeter, the Q equation changes slightly different. And so, and again, this is for bomb calorimeters. And so for a bomb calorimeter, UQ cal, or again, the heat of the calorimeter is going to only be reliant on, again, your C cal, or the heat capacity of the calorimeter, times the change in temperature of your calorimeter. And so please notice, C cal times the change in temperature of your calorimeter. No unit of mass is included in the calorimeter equation. And so, luckily for us, we're given this information inside the actual equation or the problem. And so your C cal is going to 11.4 kilojoules per degree Celsius. Your change in temp, as always, is always going to be your final minus your initial. And so we have our 24.2 minus our 21.5, and these are both in degrees Celsius. And so going through and working this out, you have your degrees Celsius cancel out with your degrees Celsius. Our final unit should only be in kilojoules. If you calculate this, you have, or I ended up with 30.78 kilojoules of energy. And remember, this is Q cal. This is the heat of combustion of the calorimeter. But when we go back and actually look at the problem, I was asking heat of combustion per gram. And so before we move on, actually, one step thing. Whenever we talk about this, the gummy bear is the thing that is exploding. The gummy bear is the thing that is releasing energy. And so if you're trying to talk about the heat of combustion, again, of the gummy bear, this value should be negative. So the Q of the gummy bear is going to be negative 30.78. And so you have to understand, again, this still has to go both ways here. And so, if we're asking about the heat of combustion, I should have stated the heat of combustion of the calorimeter. But the heat combustion per gram here, again, since we're given the Q cal, the last thing we have to do is figure out when we kind of go through and look at this, if we have 30.78 kilojoules, if we're given a conversion between kilojoules and Celsius, we can also use a conversion between kilojoules and mass. Because we know the mass, and again, is going to be associated with this amount of energy because that's what we just calculated. And so here, if we know this is going to be the energy related when you have 0.88 grams of a gummy bear, we can actually solve for all of this, and heat combustion per gram will come out to 34.98 kilojoules per gram.